My name is Francis MUTHONI. I work for International Institute of Tropical Agriculture here in Arusha. We implement a project called Africalizing, Africa Research in Sustainable Intensification for the Next Generation. And we are collaborating with the World Veg and other institutes and doing some trials on many types of vegetables in Babati. Maybe uh, maybe in Babati and other areas in Tanzania. And today I'm going to show you, many people have talked on how good the vegetable, the importance of vegetable and how they are performing well in the trials. I will show the use of remote sensing technology to extrapolate or to know where do we scale out the, the vegetable so that we can have impact at a scale. Once we do trials and we realize they have good yields, they have good income, then we use technologies based on remote sensing. There are many satellites over the sky. We are monitoring with the geographical information system. All right, the presentation is there. So my topic today is an extrapolation suitability of improved vegetables technology in Babati District and Karatu. For today, I will showcase work in Babati District on behalf of the team from World Veg and Wageningen University. Some of the colleagues are here, and if we have questions, they will come in. The issue of extrapolation is if you do a good trial at one location, the question that comes, where do we take them so that more farmers can adopt and have those good benefits of technology? So this is the outline for my presentation. I will introduce the topic, some of which I have done, and showcase where the experimental trials for some early vegetables that have been produced by Wild Veg. And then I will showcase how we integrate remote sensing and geospatial technology to guide their scaling out. And then I'll talk on how relevant are some of the maps. We have developed an index called Extrapolation Suitability Index, and we generate maps of where this cultivar is suitable, and if you are going to scale it, where is it less risky. And then I will show the future plans of our plans, of our, okay. So as we have heard from many presenters here, vegetables are very important diet components. They are rich in many essential minerals, and also it's a source of income which support livelihoods in a rural area and in the farm household. The issue is we should invest in sustainable production of the vegetables, not only for yield and profit or income, but also to ensure environmental sustainability, because we need our soils to be replenished by nutrients and their structures. So the Blue Africanizing program, where ITA within Africanizing and World Veg collaborate, we are doing trials on sustainable intensification technology in Babati. We did a trial of the two of cultivars that I will show before, and we found that growing vegetable with the integrated management practices in Babati district were giving double the yield and the benefit compared with the standard farmer practices. After those trials now, we asked, this is very good, where do we take it? Where do we start? So the question comes, where can we scale out this high yielding combination package, combining cultivars and integrated management practices so that we can scale out and many farmers adopt with the minimum risk of failures? And the solution that I will be showcasing today is leveraging the use of geospatial technology and digital agronomy to generate maps for extrapolating risk or extrapolating the technology that we have tried in the trials. I will showcase where the location of the trials. We set the on-farm trials for the tomato, and the Tengeru 10, and the eggplant, African eggplant called Tengeru White. There are so many, like 8 or 10 cultivar from World Veg that we Africanizing have been doing, but for the purpose of this presentation, I'll narrow that one. The trial has been going on since 2013, and mostly we set them in 4 villages, some on the high upland area. The background is a satellite map for rainfall in Babati. The very blue areas is high rainfall. So this is high potential zones in Bami and Seroto. We have also medium potential Galapo and low potential in Matufa. So the setup of those were experiments set in different agroecological zones. Uh, the response. So I should move. Just to emphasize on the validation, hereby I show how the validation was set up. We set in the farm showcasing the improved practices and the normal practices for the, here I show for the Tegel 10. The improved practices include manure, mulching, proper spacing, stocking, irrigation, weeding, and of course, healthy seeds. And you can see the difference on the improved practice and the normal practice. I can showcase the next one for the eggplant. Here is also one of the demo sites in Babati for African eggplant. They are planted with proper spacing. Then we keep a plant which is a push-pull for prevent of the pest. So within these trials, as I said before, we compared the income and in terms of the yield and the income for both cultivars planted with improved management practices and the standard farmer practice, and it is can see clearly for African eggplant that this is a standard farmer practice. This is an improved practice. It is clearly more than double. The IMPs produce more than double compared to the standard practice. So then it is clear we need to scale out. We need farmers to be working on improved practices. And one of the failure of the introduction is poor targeting. So this is where now we use the technology from the satellite to show farmers and extension staff where the improved practices can be suitable, so that we don't go on doing trials is very expensive. So we are leveraging the use of technology to identify the areas where it can be adopted very easily. And we use data from a satellite. Satellites are passing, they are observing our Earth every day, every hour. We have data from altitude, precipitation, temperature, soils. Last few months ago, the soil data was released at 30-meter resolution for the whole of Africa. So this among like the space of this hall. So we have very high resolution data. We have algorithms. This one I showcase this method we have done for maize, and it is published. Someone can check for the southern highlands of Tanzania. So we are adopting the same methodology to do it for vegetables. The input data for this method, as I said, we start with the data we collect from the trials from the farmers. As I had shown before, we make the best performing trials as the best reference. And of course, we have all the data from satellite. We have from the soil cation exchange, digital elevation model, evapotranspiration, market access. We have data on soil pH, soil on precipitation, there's the rainfall, sand content in the soil, the slope, the soil organic carbon. We have a minimum temperature. We have a total population, which is an indicator of the market for our produce. We have those are just a minimum, but the one we selected based on our discussion with the technical people, these are the ones which may affect or may influence the growth of these cultivars that we selected. Um, Before we going on developing the index, we have to characterize the environment that is grown. The trials are different, have different environmental condition, and we did a hierarchical principal component analysis, generally to characterize which sites have different characteristics. If, like you see, this marginal area in Magugu has a it's warm because the minimum is high. It has high sand content in the soil and high pH. But other zones in the highlands have a high precipitation, and the soil organic carbon. They have a high elevation, digital, and more populated. Another zone has a high soil exchange, cation exchange, and also the access to market is high because there are more roads. So we find that our site, we have like three types of environment, because when we are scaling out, we also have to identify the what kind of environment do we want to take. So do we target this kind of environment or do we target this one, and so that we can know which cultivar go to which type of environment. uh, I'm struggling a bit pushing forward. Then once you identify the environment, you also to have to check the yield that you have observed from the trials from those environments. We checked and we saw that from the three population of target environment, we compared the yield, and also this is the yield for the African and the tomato yield, and also this is about the yield, and this is the income, so that you can like for the African eggplant, you see the cluster, the zone one, the zone cluster zone one, and the highest median. So you might target to scale out this one. We choose the one that had highest median yield and also the income. Sometimes there are other characteristics. Some people might also target the one which are less variable in production. So once you identify, okay, like here we choose the one with the highest medium yield and also the income. We choose those one as the trials, we choose them as reference area. Then we ask, okay, this is a trial, this is the area that produces very well. So we ask our geography, where else can we find these characteristics, so that we know this area, they are highly likelihood to perform very well, just like we had, just like we observe in the trial. Then the final one, the final output, this is the extrapolation suitability index. This is the map. We show that it starts from zero. If it have around zero, the green areas, these are the best, the priority site that you should go. And it go to the negative. The higher the negative value, the site is less suitable for that variety. If I can start clearly for African eggplant, you can see the south and west side of Babati, it's not suitable. And there are other sites which are more, so the sites shown in red, sorry, it moved for one side. So the sites shown in red, these are less priority. If you are doing extension, these are the less priority, but the green side, these are the highest priority. You should go and you have less likelihood of failure. But the tomato is highly adapted in Babati, almost so everywhere, except where hilly areas where maybe there are just pockets of hilly land that were selected as not suitable. Also, we also identify among the variables that we use in making the map for extrapolation. We find which is the most limiting factor. Which, if you are to make this cultivar work everywhere in the space, what do you need to address? And for Tengeru 10, it was largely limited by evapotranspiration. These areas with a brownish color. Evapotranspiration was the most limiting factor, but here was the elevation. And also for Tengeru White, the most of the area was highly limited by the rainfall precipitation, but there's some area on the market access. So if you are to address most of the areas evapotranspiration and rainfall, so the research shows that if you invest in a soil water conservation measure and more on supplemental irrigation, you are likely to increase the yield of these varieties across the region. So that's why we now guide the extension, which are the priority things that they should, or remedies that they should target so that they can improve the productivity. So why are we doing this? What is the significance of the extrapolation suitability map? As I said before, these maps are produced to guide extension and the development partners whom are here to partner to identify priority sites for targeting and scaling. As we know, doing the trials is very costly. We can't set trials everywhere. So these are tools that help you to know where do you first target. Also for breeders, if you are setting multi-trial, multi-locational trials, also you know where do you start and which environment. By essence is you reduce the risk of failure because you are targeting the suitable environment that it has been proven. You are prioritizing allocation of scarce resources to achieve maximum impact. And as we're doing all this, we also possibly enhance adoption at the scale of those cultivars or varieties. What are our next plans for development of this tool with the team IITA and World Village? The tool has been programmed for people who have knowledge of geospatial tools, but we intend to design a simple and user-friendly mobile-based tool that can be used by farmers and the extension people with the basics tool. Once an extension staff is in the field and he want to grow a certain, maybe a farmer asks, can Tengeru 10 work in my farm? He will just use his phone and say, this is a kind of suitability, and then you can have evidence-based scaling. We also intend to integrate with Mwanga platform. It's a tool developed within the Africa Rising with the collaboration with SIAT, whereby we give a digital agronomic advisory about community map, about when do you start land preparation, when do you start with harvesting, weather information, market price. So we also we intend in the future to integrate within this so that it can be farmers can get information, advisories that are linked with the suitability of the cultivars or technologies that they are using. Once I'm coming to finishing, these are partners within the African Rising, in the World Village, SIAT, and other institutes. We also work with the TALI and government institutes within the extension. They are highly acknowledged. And this last slide of my presentation. Thank you for listening. And you can check more on Africa Rising in the internet. Thank you very much.
Thank you so much, Daktari. I will take a very quick question, just one, because we are smack right on time. We need to break for lunch. Just one question. Just one. If you have more, luckily he's here with us, so you can ask him more questions.
Hello, thank you very much. Number one is the presentation is very, very good, bringing us new information. Now you factored in some climatic parameters in your model for extrapolation. Now, how do you consider climate change and the climate variability if we want to extrapolate in many areas? Thank you.
Over to you.
Okay, thank you. Thank you for your comprehensive good question. Um, um, the, with the remote sensing, we are not limited, as I said, we are getting all those data, hourly, daily, monthly, and we can be able to use that data to do a time series analysis on climate change, and then we factor it when we are doing the modeling. And I can share more. We have done for the whole East and Southern Africa, we have done a study which is published on how the climate is changing, and then we are using the trends for climate when we are modeling the suitability of the varieties. Thank you.